Now let's look at our data for our lab. Evaporating dish provided, and then we've added 2 grams, of course, of sodium bicarbonate. And after heating and bubbling and getting all the water away, we have 35.90 grams left. So to get my grams of NaCl, I'm going to take my 35.9 and I'll subtract the empty mass of the evaporating dish to get 1.34 grams of sodium chloride that's produced in this reaction. So let's take a look at the chemical reaction then. We have sodium bicarbonate, NaHCl3, plus HCl. These are the reactants of our reaction here. This arrow means yields, and these are the products. What have we made is NaCl. And the bubbles you saw was the carbon dioxide coming off. And of course, the water left over, you evaporated away with the Bunsen burner. So we look back here. Our starting material was 2 grams of this. What was left in our evaporating dish was 1.34 grams of NaCl. Now to determine the molar mass of each of these compounds, again, we need to add 1 sodium, 1 hydrogen, 1 carbon, 3 oxygens together to get 84.0059 grams per mole. And then, of course, for sodium chloride, 1 sodium plus 1 chlorine to get 58.443 grams per mole. Pause the video now and see if you can convert the grams of sodium bicarbonate into moles and the grams of NaCl into moles. Okay, now assuming that you've paused the video and made your attempt, did you take 2 grams of sodium bicarbonate and multiply it by 1 mole over its molar mass of 84.0059 to get 0.0238 moles of sodium bicarbonate? And did you likewise the 1.34 grams of NaCl times 1 mole over 58.443 grams to get 0.022 moles of it? Okay, now we're just going to finish up with the other conclusion questions. So we're going to compare the moles of sodium bicarbonate to moles of NaCl. Okay, and hopefully you're noticing that the moles are pretty close to about equal to each other. We can go back and take a look at those. We have 0.0229 moles of sodium chloride and 0.0238 moles of sodium bicarbonate. Just a little bit of difference there due to experimental error. So why is that so? Well, we're going to use the balanced equation to do a quick mole comparison. Well, in the reaction, we see that there's 1 amount of sodium bicarbonate and, of course, 1 amount of HCl, producing 1 amount of NaCl and 1 amount of CO2 and 1 amount of water. Well, in chemistry, those amounts are moles. So since there's 1 mole of this producing 1 mole of this, we would expect then that whatever amount of reactant we put in there will get about the same amount of product. And again, that's based on moles. It's not based on grams. So if we have about 0.02 moles of this reacting, we expect to get 0.02 moles of NaCl being produced. Why is it so? Because these are actually by moles. So what we're saying is there's 1 mole of sodium bicarbonate reacts with 1 mole of HCl plus 1 mole, or makes 1 mole of NaCl plus 1 mole of carbon dioxide and 1 mole of water. Since they're all the same moles, whatever amount of moles we act of our NaHCl3, we will get the same amount of moles of NaCl. But again, not grams. Now what if we change the situation and reacted 3 grams of sodium bicarbonate? How many grams of NaCl would be produced? Well, we can do a simple proportion since we're 1 moles everywhere. We can say 3 grams of bicarbonate is to its molar mass of 84.0059 equals X grams of NaCl over 58.443 grams, the molar mass of NaCl. Remember, you had a crisscross applesauce here, and then solve for X since it is a proportion. And our X is 2.09 grams. And that's our lab molar mass as it applies to our chemical equations.